So I'm going to review Chapter 6 before you take your quiz. So the first thing we want to talk about is whether or not a distribution is a probability distribution. So just remember, in general, we're talking about probabilities. All probabilities sum to 1. So I'm looking at my table. I want to know, does 1/2 plus 1/3 plus 1/4 equal 1? And it doesn't. It actually is over 1. When we add them all together, we get 13 over 12, or 1.083 repeating. So it is not a probability distribution. So next we have a probability distribution for the number of days of work missed in a year, and we want to answer questions based on this table. So we want to find the missing probability to make this a probability distribution. So I'm going to add the probabilities we have, so 0.63 plus 0.23 plus 0.02 plus 0.01 plus 0.01, and we're going to get 0.90, which means in order for our probability distribution to sum to 1, this has to be 0.10. So 0.60, so 1 minus 0.63 plus 0.23 plus 0.02 plus 0.01 plus 0.01. Okay. Next, we want to know the probability that a random person misses more than 2 days of work. So more than 2 days would be 0.10 plus 0.02 plus 0.01 plus 0.01. Oh, no, so we don't actually need the 0.10 here because it doesn't say at least 2 days of work. It says more than 2 days of work. So that would just be 3, 4, and 5. So 0.02 plus 0.01 plus 0.01 is 0.04. Okay. What is the expected number of days of work a random person would miss? So remember, expected is just another way to say mean. So in order to find the mean of a probability distribution, we take our outcome, multiply it by its probability. So our expected value is going to be 0 times 0.63 plus 1 times 0.23 plus 2 times 0.10 plus 3 times 0.02 plus 4 times 0.01 plus 5 times 0.01. And we're going to get an expected value of 0.58 days. So, which makes sense because my highest probabilities are for 0 and 1, so it makes sense that my expected value would be closer to those days. And then lastly, we want to calculate the standard deviation. So in order to calculate the standard deviation, we first have to calculate the variance. So the variance is the outcome squared times its probability minus the mean squared. So we're going to do 0 squared times 0.63 plus 1 squared times 0.23 plus 2 squared times 0.10 plus 3 squared times 0.02 plus 4 squared times 0.01 plus 5 squared times 0.01, and then minus our mean 0.58 squared. And we're going to get 0.8836. So our standard deviation, so this would be days squared, is the square root of 0.8836, which is 0.94 days. So next we're going to take a look at the binomial and geometric distributions of Chapter 6. So if 10% of the people who are given a certain drug experience dizziness, find the probabilities for a sample for 15 people who take the drug. So we want to find the probability that 2 people will become dizzy. So this is going to be an example of a binomial distribution. So because we're trying to find the probability of R successes in N trials. And specifically, we're trying to find the probability of 2 successes in 15 trials. So we're going to do N choose R, so 15 choose 2, times the probability of success, which is 0.10, raised to the power of R, which is 2, times the probability of failure, which is 0.90, raised to N minus R, which is going to be 13. So plugging this into the calculator, we're going to get 0.2669. So for B, we want to find the probability that at least 2 will become dizzy. So this is the probability of 2 plus 3 plus 4 plus 5 plus 6 all the way up to 15. So the easiest way to do this would be to use the summation function on our calculator. Otherwise, we would have to write out the probability like we did in A a lot of times to add them all together. So we're going to start with R equals 2, and we're going to go all the way up to N equals 15. So we're going to do, in the summation, we have to do 15 choose R times 0.10 to the R times 0.90 to the 15 minus R. So this is what we need to type into our calculator for the sum so that it works. And when we do that, we're going to get 0.4510. And then for C, we want to find the probability that at most 4 will become 0. So that's the probability of 0 plus 1 plus 2 plus 3 plus 4. There's only 5 probabilities we have to add here, so we could do it by hand, but I'm still going to use the summation. So this time we start with R equaling 0, and we're going to go all the way up to 4. And then we're going to do 15 choose R, still 0.10 to the R, and 0.90 to the 15 minus R. So the only part that actually changes when we do the summations is the part that goes in for the summation itself. The formula inside never changes. So we're going to start at R equals 0 and go all the way up to 4. And we're going to get 0.9873. Lastly, we have if there is an 80% chance that a student will drive to school, what is the probability that I have to ask 5 random students before I find one that drives to school? So this is the geometric, because we want to find the probability of our first success on the nth trial. And more specifically, we want to find the probability of our first success on the 5th trial. So we do the probability, which is 0.80, times the probability of failure, which is 0.20, and then we do the n minus 1 power, so that would be 5 minus 1. So we're doing 0.80 times 0.20 to the 4th. Which is going to give us 0.00128. So less than 1% chance that you have to ask 5 students before you find one that drives to school. Let me know if you have any questions over anything from Chapter 6 before you take your quiz.